Hello, everyone. Thank you for taking the time to join us in today's webinar. My name is Mary. I'm the Marketing Director here at BLiNQ Networks. And today, Dan Stewart, our Senior Systems Engineer, will be leading you through the webinar. Joining him will be Alex Amores, the lead tech on the Flytec side, as well as other guest panelists from the industry who will offer some additional perspectives. Whether you're familiar with Private LTE or you've done some of your own research, our aim today is to provide you with some valuable insights you can take away. We'll be taking your questions, so please type them in the Q&A box and we'll try to answer as many as possible at the end of the presentation. Without further ado, I will hand it over to the Flytec team for a quick overview, and then Dan will kick us off.
Thank you for joining us, everybody. My name is Isel Torres. I'm the product manager at Flytec Computers. Here at Flytec Computers, we are distributors and resellers of fixed wireless networking, voice over IP, IP surveillance equipment located down in Miami, Florida, and down our international hub. We have over 16 years of experience in IT sales. We use that experience to help not only our customers, but our partners maximize growth. We've been partnered with BLiNQ since late 2019, and together we hope to help you guys in your LTE journeys.
All right, thank you, Alex. Can everybody hear me? Just an audio check. Yes. Okay, so my name is Dan Stewart. I'm a systems engineer for BLiNQ Networks. I've been in the industry, the wireless industry, now for 35 plus years. My previous employment was with Telrad, and then before that was with Ericsson. Kind of grown up with wireless when 802.11 wasn't even a thought on anybody's mind. So I've kind of been immersed in the wireless industry for some time. I am not the king know-it-all, though. I'm still learning today, and hopefully I can share with you what I've learned and some things about Private LTE. This course is not meant to be, or this presentation is not meant to be a LTE primer course. So just wanted to make sure you guys were aware of that. Okay, something's gone wrong. Okay, Mary, I cannot. Okay, Mary, is this screen looking correct? I'm having the poll showed up.
Yeah, that's for the audience. That's for the attendees. So you can keep moving ahead, and the attendees will are free to answer the poll, and it'll run for about a minute. So. Go right ahead, Dan.
Okay, sorry. So what we're going to be talking about is, the basics of Private LTE, why it's the right choice, and how BLiNQ can make the installation easier, better, faster. Just like $1 million, $6 million man there. We're cooking along really well, and we're growing very fast, and hopefully we can share with you the reasons why. So I'm going to go ahead and move right into the next screen here. Okay. Technical difficulty. Yep. Mary, I have lost my ability to control my screen.
No worries. You should be able to hit an arrow down or an arrow across.
That's what I'm doing, and it's just moving me around in the slide. I think it may have been because of the way the poll came up.
Okay. Maybe you can stop the share and then restart the reshare.
That's exactly what I'm going to do. Sorry, folks. I'll be right back. There we go. Okay. You gotta love the modern technology here. So we're going to talk a little bit about what Private LTE is, Private LTE, basically LTE stands for long-term evolution. Private LTE is basically the standards-based LTE that we use for our phones, only it's scaled down to fit the needs of the individual entities, smaller entities. These entities could include, large corporations, industrial, automotive, manufacturing, utility, metering, logistics, you name it, smart cities, drones, transportation hubs, hospitals, enterprise, education, stadiums, and other venues. It's pretty much the secure solution that is kind of taking over the whole Wi-Fi industry right now, at least in public venues. So private LTE networks have all the advantages of commercial carrier networks, such as security, mobility, and compatibility with a wide variety of existing handsets. We're going to talk a little bit about the standard here in a few minutes, but that's probably the most important piece of LTE, the fact that it is a standard. And I believe that this will be the de facto standard for fixed wireless access. It's already become the de facto standard. But those that are still selling their proprietary solutions, I believe, are going to be migrating over to the LTE standard, or they're going to be losing a lot of business, just simply because it's really caught hold now. So why is private LTE the right solution? So many businesses have relied on Wi-Fi to meet many of those needs, but while Wi-Fi offers high value for the investment, it still falls short when compared to private LTE in terms of security, configurability, upgradability, scalability. So Wi-Fi, it is at a lower cost, but it's not nearly as robust as LTE, and it doesn't offer the breadth of features that LTE does. We've lately, in the last 3 or 4 years, seen a real resurgence for LTE and fixed wireless applications, and the primary reasons are really threefold. One is the technology, the advancement in silicone, and improvements in antenna design, wavelength propagation, and all that cool stuff that you're hearing right now about beam steering, beamforming, tracking. They're all contributing to a lower cost base, which results in a much more attractive return on investment. The demand is the other thing that's really driving this. Because of the demand, we're seeing underserved markets now being funded by things like the government digital divide funding, that sort of thing, which are really creating a ripe environment for investment and innovation. The recent pandemic has created a huge demand for high capacity in the situations of distance learning and work from home. If you're a wireless ISP out there, I dare you to tell me that that's not the truth. You're probably up to your ears in alligators right now, just trying to service the many number of customers that are asking for higher capacity and access. So the third thing is really the cost. So technology and demands are helping to make the business case a lot more attractive to operators. So fixed wireless access, it was introduced when most people were using dial-up. That was basically WiMAX, but it was really hard to compete with the other emerging standard, which was 3G and 4G. And as a result, both the technologies were hampered by a lack of scale, which meant the costs were very, very heavy. These days, what we've seen is a huge drop in price and availability for private LTE networks and solutions that are much less complicated than what some of our competition outside the private LTE solutions are. That's probably their chief negative comment is, well, it's way too complicated. I was actually reading today about an article that was claiming that there's more than 1,000 features and fields that you have to process through to bring up a private LTE network. Reality is much less. I would say it's less than 100 things that you have to configure, probably more on the lines of about 50. So the complexity is much less than what the competition would have you think. So what we want to talk about a little bit is the spectrum for fixed wireless access. Basically, there's three groups. There's a licensed spectrum, where carriers can license their spectrum and they build out a private LTE network for an enterprise. The biggest problem with that, as we're going to see, is licenses are fairly expensive and they're very hard to come by. And then you have the unlicensed spectrum. The unlicensed spectrum is primarily in the 2.4 gig and the 5 gigahertz band. The problem we have with that is that everybody and their brother, Joe's Pizza and Internet Shop wants to, put up a base station when they've absolutely no clue about RF, and they end up killing or degrading fixed wireless access companies that are deploying. So those bands, while they are very familiar to all of us, they definitely have the negatives. And then we have the shared spectrum. And we're going to talk a little bit about that. We're not going to get heavily involved in the CBRS. If you'd like to learn more about the CBRS spectrum, feel free to give me a shout. But we're going to talk a little bit about the CBRS spectrum. So here's a quick chart about the different frequencies. We got the 2.5 gig. Of course, this is the licensed band. It's 200 megahertz of licensed spectrum, and it definitely has the best propagation among all the TDD spectrums. But the cost of acquiring the spectrum is very, very expensive, and the majority of the spectrum in populated areas are already owned. So it's very difficult to actually deploy that these days. And then we have the 3.5 gigahertz band in CBRS. Consists of 150 megahertz of spectrum. It's a global LTE ecosystem, meaning it's standards-based, and it's a very good balance between propagation, power, and reuse. It is a new technology, but it's taking off like crazy. Last I saw about the auctions for PALs, they've managed to sell $1.4 billion worth of priority access licenses for CBRS, and they're not even finished with the round. So, and then you have the 3.5 gigahertz band 42 and 43. Now, this would be applying to outside of the United States. It's also a worldwide use, and again, it's a good balance between propagation and power and reuse. The country-specific rules are something that I cannot speak to directly in this. If you have a specific country that you're looking to deploy in mind, we can certainly help you determine what those rules are and that sort of thing. But they are very country-specific rules, and they kind of change mostly with regards to maximum EIRP, which is the maximum transmit power. And then finally, has the 5 gigahertz band. Just recently, the FCC said that they're going to be auctioning off 280 megahertz to priority access license in the 5 gigahertz band. So that's very, very promising. You're going to see more to come from other companies, including BLiNQ, with regards to this as well, where you might see the capability to utilize both the CBRS band and the band C at the same time and be able to do channel aggregation, providing much more capacity, that sort of thing. All righty. So the primary LTE components that you have out there are the UEs, the UMTS, which is basically a group of base stations providing a coverage in a specific area. And then you have the evolved packet core, which is called the EPC. The UE, it's user equipment, any device that allows 4G network communications. It's not just CPEs that the fixed wireless access folks have. We actually have trials that have gone on with Apple iPhones actually being able to utilize that same band, the CBRS band. So it can be literally anything: tablets, smartphones, IoT devices, and then we have the evolved packet core. This is essentially the back end, the LTE subscriber's home, if you will. It's a control center that keeps track of authentication of the UEs, SIM card management, administration of user services, radio profiles, that sort of thing. This is where, when I talked about the complication, where it's been challenged by some of those naysayers of LTE, saying that it's way too complicated, when in reality, companies like BLiNQ Networks have actually broken down the EPC into very specific parts that operate for fixed wireless access and make it much more simpler to deploy. And so this is what the EPC looks like. This is what the EPC looks like in its core, basically. So, excuse me. So the first thing you have is the S1. The S1 is basically an interface that connects the E node B to the EPC. It's just an interface. It's split into two control panels, one called the S1 MME and the other one, the S1-U, which stands for the user plane. The S1 MME is a signaling interface which supports a set of functions and procedures between the E node B and the MME. The role of the S1U is to transport user packet data between the E node B and the SGW. Speaking of the serving gateway, it basically routes and forwards user data packets while acting as the mobility anchor for the user plane. Then we have the packet data network, which acts as an interface between the LTE network and other packet data networks, such as the internet or SIP-based IMS networks. It terminates the SGI interface towards the packet data network. The SGI, in case you're wondering, is the reference point between the PDN gateway and the packet data network. So the MME, the mobile management entity, is a control plane entity. And it's the main control node that processes the signaling between the UE and the core networks. The main functions supported by the MME are functions related to bearer management, the establishment, maintenance and release of the bearers, that sort of thing. Security functions for both the signaling and user data are also performed here. And then we have the HSS. You're going to hear a lot about the HSS because that's your primary interaction for the home. It's called the home subscriber server. And it's basically a centralized database of subscriber information. So this is what holds all the IMSI information and all the details of the profile for specific UEs. That's essentially what that is. And the HSS basically relays this information to the network using a protocol called diameter. Not that that's really important, but that's what it's doing. So. And then the PCRF, this is a policy and charging rules function. It acts as a policy decision point for policy charging and SBF applications, IP bearer research, switches, that sort of thing. So we're going to talk a little bit about private LTE use cases outside of fixed wireless access. There's a lot of interest by large companies that are looking at creating or deploying a private LTE solution specifically for things like airports and hospitals, hotels, manufacturing, municipalities, ports, rail yards. Pretty much all the public venues, stadiums, and schools and universities are looking at using this. And the reason why is that the Wi-Fi just does not provide all the capabilities that LTE provides, like critical communications for security and operations teams. You're hearing all the time about how Wi-Fi systems can get hacked into or interfered with, that sort of thing. So we're seeing a lot of movement in industrial areas. We're working with some mining applications, and we're also looking at or working with some municipalities in deploying private LTE for just the cities. So lots of really interesting uses for this. We're going to talk a little bit about the BLiNQ product line now. So the BLiNQ key technology propositions, they're really basic. It's easy to deploy and easy to scale. Okay, so the BLiNQ products, unlike all of our competition, we have a really strong uplink and robust link adaptation for foliage and wind. What that means is that we operate really well in non-line of sight conditions. Now, I want to qualify that because I've been told several times where people want to deploy a base station at 100-foot height and the trees are 120-foot high, and they're wondering why they can't get a mile of coverage. That's just not reality. There's certain important factors that need to be determined when you're deploying base stations and that sort of thing. So while it is non-line of sight and it operates really, really well in non-line of sight conditions, don't expect to be going through a forest full of trees in a situation that is less than desirable from a deployment standpoint. We have a really cool adaptive antenna system where you can actually vary the antenna location and capacity to focus where you need the throughput. And what's even more important is that our product, the FW300i, is actually a fully integrated, it has antennas, GPS, everything, including if you want an EPC, all built into one box. So that's just like really, really cool. And we support, right now we're supporting 2cc, and in the near future we'll be supporting 3cc. What that means is a CC is a common carrier. What that typically means is when you deploy a 20 megahertz channel, you can combine two 20 megahertz channels to have 40 megahertz of bandwidth capable, or even 60 megahertz of bandwidth capable in a 3cc beam sector kind of solution. So the thing that you'll always be seeing from our standpoint that we talk about a lot is that it's a standards-based solution. Standards-based solutions make it much easier to deploy, and you're not locked into a single vendor. All our products are on-go certified. Being on-go certified, that's the CBRS team that has set the standards for being interoperable. And so if you're on-go certified, you're totally interoperable with any eNode B or EPCs. So that's really the big takeaway from the slide. The FW300i, as I said, it's an all-in-one integrated EPC solution. What you're looking at, that box right there, the little white box right there, is literally 3 antennas and 3 eNode Bs, all inside one enclosure with a GPS. And like I said, you can actually deploy this with an EPC embedded in the 300i. So this takes place of all those RF cables and big antennas that you have to deploy. So the deployment itself is very, very quick and much easier. And again, like I said, we have this capability. I'm not sure why that's not. Sorry, guys. There we go. Sorry about that. So, what this graphic is showing is basically the capabilities that you have of moving an antenna over to another sector and doing a carrier overlay. What we mean by a carrier overlay is 2 20 megahertz channels independently running, or you can make a carrier aggregation where you're actually using 40 megahertz and up to 60 megahertz out of that one eNode B. So it's just a phenomenal solution. You can have up to 96 users per sector, up to 288 per FW300i. One thing I want to make sure that you guys are all aware of is that when we say 96 users per sector, that's the maximum amount. It's not the typical amount that you will see in a fixed wireless access solution. It just doesn't happen that way. Okay, the throughput is all divided by those users, so you're going to have an oversubscription rate. Where you will see situations where you can have up to 96 users is in IoT solutions, the Internet of Things, where imagine you're deploying for a company that's got wind farm applications, and they've got sensors, IoT sensors everywhere across their wind turbines and that sort of thing. You can easily get to 96 users in that situation where it's a very small capacity, low capacity, but low latency requirements as well. So there are situations where you will see 96 users per sector. Typically, it's somewhere between 25 and 50 users per sector that we typically see. But again, this can be ramped up. It just depends on what packages that you're selling to the customer. So this is just another example of doing that carrier overlay. If you have any questions about that, hopefully this will help to explain it a little bit, but we're the only one in the industry that has this kind of capability. So the X300i, it's actually a 3-sector unit. This is meant to go to set upon street lamps, if you will, or street light poles, traffic lights, that sort of thing. So it can supply up to 500 megabits of aggregate capacity, and we do have that capability to do antenna switching, albeit it's limited. You can actually, let's say, instead of 360-degree coverage, you only needed, 240 degrees of coverage. You can actually electrically move an antenna to another sector and do a carrier overlay or a carrier aggregation in that situation. So we'll talk a little bit about the BLiNQ EPC solutions. As I alluded to, we have a integrated EPC solution as well as a external EPC solution. The embedded EPC is really the simplest and most cost-effective deployment model in deploying eNode Bs. The user traffic is broken out at the eNode B, as you can see in the diagram. Each eNode B acts as a self-contained network in a box and can operate autonomously. Centralized management of EPC and eNode B can be done from NetLiNQ, which is our network management system. This is really cool, and it should be thought of as a potential solution as well for rapid deployment in emergency situations. You can literally bring up 2 of these in a matter of a couple of hours, put it on a cell on wheels kind of tower, and provide emergency LTE coverage very, very quickly, like I said, in a matter of hours. The centralized EPC, its primary purpose is to be scalable, where we're talking about instead of the integrated EPC solution, which is talking about, you know, maybe a couple of hundred users, that sort of thing. We're really talking about hundreds of thousands of potential users. So it's very, very scalable. So that's the reason why you take it out and put it out at the core. Essentially, the eNode Bs are connected via a private network to a central location. The user traffic is broken out centrally, as you can see in the diagram. If roaming is necessary in your application, this is what you need to choose. In other words, you cannot roam between EPCs, if you will, in a integrated EPC solution. You can roam between the 3 sectors, but if you have 2 back-to-back, you can't roam between those 2. If you wanted to roam, you wanted to provide that roaming capability, we fully support it, only you'll have to move to a centralized EPC solution. Hopefully that's pretty clear on that. So talk a little bit about our BLiNQ outdoor CPEs. The category is basically used to allow the eNode B to communicate effectively with all the UEs connected to it. The UE category defines a combined uplink and downlink, so that's the reason why you see this category configuration. You know, category 6 and category 12. The kind of throughputs that we're talking about on the category 6 is 220 megabits. There are specific requirements that you have to use when you're configuring it this way. But we can talk about that offline, or you can learn about it on one of our other webinars there. With the category 12 CPE, 440 megabits of downlink and 30 megabits on the uplink is capable if you're deploying in a 3CC solution. I've recently been testing up in Denver, and our CPEs pushing about 260 megabits on a 2CC solution, which is really, really impressive, I think. So pretty much everything else is the same. We have a slightly higher gain antenna gain on the category 12. If you're wondering which one to go with, quite honestly, I would always pick the category 12 because as we expand and we go to 3CC solutions, you're not going to be able to utilize that unless you do that, the category 12. And then finally, we have our NetLiNQ network management system. The NetLiNQ management system, it has full EMS capabilities, full network management functions, so you can manage each one of the eNode Bs independently. You can manage the HSS. You can manage pretty much everything that is about that network from your EMS. It's primarily there, though, for collecting and reporting data, so that you can look at KPI information, that sort of thing. So that's pretty much everybody's got one of those, and we got one just like it. So as a key takeaways, we talked about BLiNQ's private LTE solution, which leverages the 3GPP standard. It's all about interoperability, folks. I mean, if you're really wondering, you know, should I go with an LTE or should I go with a non-LTE, non-standard based system, there's all kinds of reasons why you should not be using a non-standard based solution. It's just like 802.11. I was in the world before 802.11, and there was a system called frequency hopping, and it was all the rage for about 2.5 years. And everybody was thinking frequency hopping was going to take over the world. And then 802.11 came along and kind of limped in, but then very quickly took it over, and now it's, you know, bloomed because it's standards based. So the same thing is happening with LTE. BLiNQ is affordable. It's easy to deploy. I've already explained, you know, why it's easy to deploy. You don't have to mess with RF cables and external antennas with the FW300i, and we also, with the 300X, the smaller one sits on a light pole, allows you to fill in coverage gaps. Let's say if you're in a municipality, that sort of thing. So we've simplified the learning curve, and I can attest to this. The learning curve for LTE used to be very, very high. I spent 12 years with Ericsson and still didn't get everything down, still was learning. Where with BLiNQ, we've really simplified what's needed to provide a simple solution for private LTE networks. And I think if you choose to evaluate the product, you're going to find that to be the absolute truth. So, at any rate, I think that's about it. If you guys have any questions, I know I've seen questions come up. I kind of raced through this, so I apologize if you guys have questions.
Yes, a few questions actually did come in, and I think it'll be good to share these now. We've got a good amount of time to answer a few questions, so please keep sending some through. One question that came in, does private LTE require licensing? This is for you, Dan, and for any of the panelists who might want to chime in on this question.
So private LTE in the CBRS world, you basically have 150 megahertz that you can operate in. 70 of those 150 megahertz could be licensed to a what they call priority access license user. Okay. And those were the auctions that I talked about, raising $1.4 billion in the U.S. in the last month and a half. So up to 70 megahertz of that 150 megahertz could be allocated directly to a PAL provider, but not necessarily, because those auctions are by individual county all across the U.S. And it's also a use it or lose it solution. So even if the PAL has it, but they're not using it, you can still operate in that band. So quite a bit of band that you can operate in. If you're going to deploy outside the U.S. and you're going to deploy, you know, like in the band 42, 43 arena, most of the countries have specific licenses that you have to obtain. So yeah, so did that answer that? I hope.
I hope so. But
Okay.
With any other questions, we can follow up with emails. So if there's anything from this deck that you want clarification on, feel free to send through your email, and we can talk to you one to one. We've got another question here. Is CBRS technology implemented in other countries, Brazil, for example?
No, it's not. Now, shared spectrum is going to spread. I can guarantee you that. I know the UK is looking at that, and while some other countries over in the European area, Brazil specifically, I have not heard of any shared spectrum or spectrum sharing there. So if you're going to operate in Brazil, I think there's actually a Brazil licensing agency. Is it Anatel? I can't remember, but yeah, you'd have to operate with the license if you were talking about in Brazil. CBRS right now is strictly under the U.S. Now, that doesn't mean that BLiNQ products cannot operate outside of CBRS. BLiNQ products can operate in both band 42 and 43, with no more bands coming here. So, so you can still operate our product. You just won't be operating under the guise of CBRS, where you have to get a SaaS provider and that sort of thing.
Okay, we have a question here about the FW300. Is it, going back to your slides earlier, is it 96 devices, phones and iPads that can be connected through the FW300? Is that the capacity?
So as I was trying to allude, so you have, let's talk specific speeds and feeds for a second. So on a standard 20 megahertz channel, nothing special going on here. You can get approximately 100 megabits, 100 to 110 megabits down, and 10 up. Okay, that has to be divided among the users, and of course, it's only when they're transmitting. So it's not like, you know, you got 50 users, then you have to divide that 50 by 100, and that's all they get. It's only while they're actively transmitting, but it is divided by that amount, okay? So obviously you're not going to be, at least I hope it's obvious, that you're not going to deploy 96 users on one sector, on a single sector for fixed wireless applications like home learning or remote learning and you know, home office kind of thing. Usually that bandwidth is anywhere from 10 to 25 megabits per second. Some of them are requiring 50 megabits per second. So you have to do oversubscribing. That's why I alluded that with fixed wireless access, CPEs, you'll see anywhere from 20 to 50 CPEs per sector. That there is no hard limit. It's just the limit of what that capacity is capable of providing. Keep in mind that you can go to 2CC, which is two carrier components combined at 40 megabits per second. This is where I was telling you I was getting 260 megabits. So imagine that, 260 megabits divided by, again, the number of subscribers that you're going to oversubscribe to. Okay, so the fact that we can do 96, we do have situations that we've been working in where we're talking about Internet of Things kind of situations, you know, farming, mining, all that sort of thing, where their throughput requirements are not really high. They just need low latency requirements because they're pulling sensor data and that sort of thing. That's where you could easily have 96 users. Okay, and of course you could have a combination of that. You could have fixed wireless access and IoT. You could have phones. You could have iPads. You know, a combination of these things.
Okay, I've got another question. Is the SaaS server access included in the products, or does the user need to procure it separately?
Can you repeat that question? I think was it a SaaS question?
Yes. Is server access included in the products, or does the user have to buy it separately?
Yeah, so with BLiNQ, we support all of the major SaaS providers, Federated, Google, those guys, CommScope. We support all of them. The SaaS is basically the entity that controls the transmit power and the frequency use on a CBRS system. It does that so it can protect the incumbents and the PALs, the priority access license users. If you're operating CBRS, you have to connect with the SaaS. And so rather than pick one and go with one, we made sure that we could support all of them. So it's totally independent to the user. One other thing that's really nice about our products that some products don't have, this is part of my CBRS presentation, but one of the things that you can do is the eNode B, the base stations themselves can actually register with a SaaS directly. They don't have to go through what's called a domain proxy, which again makes it really quick for rapid deployment situations and emergencies, that sort of thing. I think this is a no-brainer to sell to the local communities for just rapid deployment of communication systems during an emergency. Imagine a tornado, a bridge falling down, who knows what, where you could actually go out and deploy one of the BLiNQ solutions. And again, it's very, very simple to deploy.
Okay, great. One last question before I turn it over to the panelists. Are the radios capable of 5G modulation, and is there a 5G upgrade path?
I would say absolutely. The whole 5G moniker is a little bit confusing, and it's kind of wielded kind of sloppily. So I would say, yeah, absolutely. We have a path to 5G, and we're doing it now. We have a roadmap where we're supporting 5G. And in some cases, you could actually consider the fact that we're doing 5G-like solutions in the 3.5 gig manner right now, and moving up to 5 gigahertz. And the C-band is very, very capable, very possible.
Awesome. Thanks, Dan. I just wanted to pass it over to the panelists to see if there's any other questions or comments. And I'll hand over the floor to Flytec if you have any other comments.
Mary, to clarify that SaaS question that came through, I thought the question was whether the SaaS costs were included with the product, and the answer to that is no. You have to contract directly with the SaaS provider to set up an account, and as Dan said, the BLiNQ radio will talk to any of those SaaS providers, but that's a separate fee that comes from the SaaS provider themselves.
Okay, thanks for clarifying that, Dan. I think that was what the question was asking. Another question just came in actually. Does our EPC include any network slicing functions like separate APNs for different purposes? So did you guys hear that question?
So I think this one in the chat already, Mary, but yes, I mean, network slicing in terms of having multiple APN support. APN support, is basically a function of the packet core in that sense. So you can have multiple APNs for different usage if you want to segment traffic, etc. So it depends on what it is. We have limited support, meaning there's a limited number of APNs that we can support on the embedded EPC. On a centralized EPC, it's really what the limitations of a centralized larger EPC might happen to be in that sense. But the ability to support multiple APNs is there from that side. So
Great. We've got one more question. What mechanisms do you have for controlling QoS, different UEs, throttling, APNs, prioritizing or deprioritizing data caps? I think, Patrick, you answered this privately, but it might be of interest to the audience as well.
Yeah, so again, software, the EPC is effectively, as Dan says, it's command and control for the network. So the EPC is what actually controls most of those functions as well in terms of QoS, throttling based upon, customer requirements, managing data caps. That's all part of the, basically the PCRF and its sister component called the PCEF, which is the control and enforcement function that says, if you wanted to do certain things, like if you wanted to block Facebook, for example, that's a function of the EPC and the PCEF. Things along those lines, enforcing data caps, all that kind of stuff is a function of the EPC. So we have those capabilities within the packet core, whether it's the embedded packet core or a centralized packet core, whether it's something that BLiNQ provides or it comes from an independent third party.
Great. I think those are all the questions that we've received so far. Does the panel have any other comments before we wrap up? I think that's a no. Okay, so Dan and Isel, thank you for leading the presentation, and to all the attendees, thanks for participating. We really hope you can join our future webinars. Like I said, if you have any other questions, feel free to reach out to me. My email address is in the webinar confirmation, so you should be able to reach out directly if you need to. And hopefully we can continue this conversation with you offline. And that's a wrap. Thank you, everyone, and have a great rest of the week.